Okay, this is the first question, and the question says, a 15.75 gram piece of iron absorbs 1086.75 joules of heat energy, and its temperature changes from 25 degrees Celsius to 175 degrees Celsius. Calculate the specific heat capacity of iron. So we have our variables here. Q would be the heat energy that was absorbed. So we have 1086.75 joules. And then M would be our mass, so we have 15.75 grams. And then C is our unknown variable. It's the specific heat capacity. And then we have delta T, which is our change in temperature from 25 degrees Celsius to 175 degrees Celsius. So to calculate this, we just plug these numbers back into our equation, Q equals MC delta T. And so we have 1086.75 joules is Q equals 15.75 grams. And then we have X as our unknown, and then 150 degrees Celsius as our delta T. And then, so first we will multiply these two together just like in a two-step equation. So, we have 15.75 times 150, and that gives us 2,362.5. So we rewrite our equation. Equals 2,362.5 Celsius, and then X. So now to get X alone, we'll have to divide this and divide it over here as well. And so we have 1086.75 divided by 2,362.5, and that gives us 0.46. So X, or C, or our specific heat capacity would equal 0.46 joules over grams degrees Celsius. Just like that. So the question is the second question, and it's how many joules of heat are needed to raise the temperature of 10 grams of aluminum from 22 degrees Celsius to 55 degrees Celsius if the specific heat of aluminum is 0.9 joules over grams degrees Celsius. So first we're going to find our variables, and the Q is the amount of heat, and that's what we're trying to find out, so that's unknown. And then M is the mass, and our mass would be 10 grams. So 10 grams. C would be the specific heat, and our specific heat is 0.9 joules grams over there. And then the change of temperature would be, we're going from 22 degrees to 55 degrees, so that would be 23 degrees difference. So now that we have that, we are going to plug in our numbers into our equation. So we have Q equals 10 grams times 0.9 joules over grams degrees Celsius, and then 23 degrees Celsius. And then you just type that into the calculator, which we have right here. So it's 10 grams times 0.9 times 23. And we get 207. So this is equal to 207. And since we have to cancel out our units, so we have grams above the line and below the line, and we have Celsius above the line and below the line. So we're left with joules. So this is joules, and our final answer would be 207 joules of heat. Okay, so this is the fourth question, and our question is 100 grams of 4 degrees Celsius water is heated until its temperature is 37 degrees Celsius. If the specific heat of water is 4.18 joules over grams degrees Celsius, calculate the amount of heat energy needed to cause this rise in temperature. So I already figured out the numbers for our variables. Q is the heat energy that we're trying to find out, so we don't know that one. M is our mass, and our mass is 100 grams. C is our specific heat, and it is 4.18 joules over grams degrees Celsius. And then delta T would be our change in temperature, which we're going from 4 degrees to 37 degrees, so that's 33 degrees. So now we plug that into our equation, and we have Q equals 100 grams times 4.18 joules over grams degrees Celsius over, or times 33 degrees Celsius. And we want to cross out our variables, and so we have grams above and below the line. We have degrees Celsius above and below the line, so we're left with joules. So our final answer will be in joules. So now all we have to do is multiply those numbers, and we have our calculator. 100 times 4.18 times 33 gives us 13,794. So we write that. 13,794. And so that is the amount of heat energy, and we're left with joules. So the joules would be our unit, and that's our final answer. So it takes that much heat energy to go from 4 degrees Celsius to 37 degrees Celsius with 100 grams of water.